All right, so today we're going to talk about multiplying a binomial times a binomial. Up here at the top, they've got some information on the FOIL method, and we're going to ignore the FOIL method for now because I want this to look just like what we did on the last set of notes on a monomial times a binomial. So it's going to look very similar, not exactly the same, but it's going to look very similar. So we're going to do example 1, so x plus 2 times x plus 1. All right, so the first thing that we're going to do here is we're going to think about this as two separate distributive property problems. We're going to think about this as being x times x plus 1 plus 2 times x plus 1. And now that we've broken this up into two different terms, it looks an awful lot like what we did yesterday. So we're going to start with the first term. We're going to start with this first distributive property. So x times x plus 1 times x. And then we're going to do the second set of parentheses, plus 2 times x plus 2 times 1. Then we're going to go through and we're going to simplify. X times x is x squared. 1 times x is 1x. 2 times x is 2x. And then 2 times 1 is 2. Then we're going to take our two middle terms and we're going to multiply or add them together. We're going to look for our x terms and we're going to add them together. So 1 plus 2 is 3x. And then we copy everything else down. So x squared plus 3x plus 2. So real quick, let's go back through it so you can see how we did this. So the first thing that we did was we broke it up into two separate problems. The first term, x, times the entire second parenthesis, followed by the second term in the first parenthesis, the 2, times the whole second parenthesis. Okay, so then we break it up into two separate distributive property problems. X times x is x squared, so x times x is x squared. X times 1 is 1x. 2 times x is 2x. And then 2 times 1 is 2. Then you look and see what can simplify. So these two are able to simplify. 1x plus 2x is 3x. So we're going to do the same thing. We're going to do a few more examples. We're going to do several examples. And notice they have this box method here. I'm not going to go, I'll go over one of those at the end, but I'm not a huge fan of the box method. So we're going to try to skip that and just stick with distributive property for the most part. All right, so we're going to come over here and we're going to do example 2. And so let's do example 2. So I'm going to recopy. So now we're going to do example 2. Now we're going to rewrite example 2 over here, kind of in the top right corner. So we're going to do this up here. Y plus 3 times y minus 4. All right, so the first thing that we're going to do is we're going to rewrite this as y times y minus 4 plus 3 times y minus 4. So notice the second parenthesis went to both of those coefficients. All right, so from here, we're going to do y times y plus y times, and remember your sign, negative 4. And we're going to do the same thing with the other term. So plus 3 times y plus 3, I ran out of room again, 3 times negative 4. So all we did was we distributed the y to both of those and the 3 to both of those. So y times y is y squared. Y times negative 4 is negative 4y. 3 times y is 3y. And then 3 times negative 4 is negative 12. And then from here, we are able to combine those because they both have y's, and that gives us y squared minus 1y minus 12. All right, so I'm going through all these steps, and again, this is the same as yesterday. I'm going through all these steps so that when we get to factoring later on, we'll have a really good idea as to what is happening. Now, a couple of things I want to draw your all's attention to on both of these examples. So on both of these examples, I want you to pay attention to the signs. So inside of the parentheses on both of these, we had x plus and x plus. And so when we got down here to our final step, we added these two x's together, and we got a bigger positive x value right here. On this example, one of our signs was a plus, one of our signs was a minus. All right, so look at what happened. We had 3 positives and 4 negatives. We subtracted those right here and ended up with a negative 1y. So one of the things I want you all to pay really close attention to as we move forward is I want you to look at the signs of the original problem and how the signs ended up down here and at the final answer. Also notice over here, our last step is to multiply the final 2 numbers together, 2 times 1. That was our last step. You can't really see it because of how I moved this around, but right here, 2 times 1. Okay, so we did this 2 times this 1. And a positive times a positive is a positive. Okay, so I want you to really pay attention to what's happening with the signs. Over here, we had a positive times a negative as our last step. And that ended up being a negative 12. Okay, so anytime that your 2 signs are opposite, your final term is going to be a negative. Anytime your signs inside of your parentheses are the same, your final term is going to be positive. Also, I want you all to think really carefully about how we get this middle term when we simplify. Okay, we had a bigger negative, so negative 4, than we had of a positive, and so when we added those 2 together, the negative 4 and the 3, it gave us a negative 1. So watch all of these things. As we go through, watch all of these. So I'm going to erase all of this. That way, see if it'll... We're going to keep working out some more examples. So a couple of things I want us to pay attention to. So we're going to do example 3. So example 3, we have a minus 5 times a minus 7. Okay, so again, pay attention to the signs. Let's do some predictions. Prediction number 1, because both of these signs are negative, when I do my last term times my last term, a negative times a negative is a positive. So our first hypothesis is our last term is positive. And then when we go to do our middle steps, we're going to end up doing negative 5 times a and a times negative 7, and then we would combine those. So we think that our middle term will be negative. And so let's see if our hypothesis holds true. All right, so we're going to walk through the steps. We have a times a minus 7 plus a times, plus b, or plus negative 5 times a minus 7. So let's look and see if our hypothesis is correct. So a times a is a squared. A times negative 7 is negative 7a. Negative 5 times a is negative 5a. And negative 5 times negative 7 is positive 35. All right, so now we're going to combine our terms in the middle. So negative 7 plus negative 5 is negative 12a. We're going to bring down the things that we haven't changed. And let's check our hypothesis. Our hypothesis is that our last term is positive, and it is positive 35, and our middle term is negative, so negative 12a. So again, when we get to factoring, it's going to be really important for us to remember how and why we got the signs and the values for these 2 terms. All right, so now these last 3 examples are going to follow the same similar pattern as the first examples. The only real difference on these being that now instead of just having no coefficient in front of our variables, we have a coefficient. We have a value, a 3 here, a 5 here, and in this example, we have a 2 and a 3. All right, so I'm going to do example 6, and then we're going to jump down and do example 7 and 8. And then we're going to do these bottom 3 examples because they look a little bit different. All right, so example 6, and then 7, 8, and 9. So example 6, it's going to be the same thing. 2n minus 7 times 3n plus 3. It's going to be the same steps. We're going to do 2n times 3n plus 3, and then plus negative 7 times 3n plus 3. So we're going to distribute. So 2 times 3 is 6. N times n is n squared. Remember, n squared. Remember, a squared. All right, over here, our first one was x times x, which is x squared, y times y, which is y squared, a times a, which is a squared, x times x, which is x squared, b times b, which is b squared. So remember, we're increasing the degree of that first term. So 6n squared And then 2n times 3 is plus 6n. And then negative 7 times 3n is negative 21n. And then negative 7 times 3 is negative 21. So let's go back and check our signs. We have one that's negative and one that's positive. So our last term is going to be negative. Okay, and so because the 7 times 3 is more negative than the 2 times 3, our middle term should end up being a negative. So let's see if we're right. 6n squared, and then our middle term is going to be 6 minus 21. 6 minus 21 is negative 15n, and then minus 21. So there is our final polynomial that way. A couple of things to pay attention to. And so far, in every one of the examples that we've done, what we have is we have a linear term times another linear term. So we have a linear term, x plus 2, or factor, linear factor, times another linear factor, and that gives us a power of 2, and that's called a quadratic. So what we're creating right now are called quadratics. Okay, something to the second power being the highest degree. So watch that. Okay, so let's look at example 7. Example 7 is a special case, and I'm not going to go into great detail on special cases just yet, but I do want you all to pay attention to what happens on example 7. So I'm going to clear my screen here. I'll be right back. So on example 7, one thing I want you all to pay attention to as you're doing these is sometimes we'll end up with the same linear factor times itself. So think about this in another way. Think about this as being 2x minus 5 squared. Okay, this, you're going to see this a lot. All right, so we have something, a linear factor squared. And so what we would do is we could write it out as expanded form, 2x minus 5 times 2x minus 5. Concept's still going to be the same. We're going to do 2x times 2x minus 5 plus negative 5 times 2x minus 5. 2x times 2x is 4x squared. 2 times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And then negative 5 times negative 5 is positive 25. Now I want you to notice what happened on this one. Notice because our signs and factors were identical to each other, this middle part got doubled. So I have two negative 10s, so that's going to be negative 20x. Okay, also notice that because our factors are identical, this first factor, this first term, 2x times 2x, is a perfect square. Perfect square. 4 is a perfect square, and x squared is a perfect square. And then the same thing on our last term. Because we're doing negative 5 times negative 5, we're multiplying as something times itself. So that's negative 5 squared. We end up with this perfect square. All right? So this has a name. And when you see ones like these are called perfect square trinomials. And the reason why it's a perfect square trinomial is our first term and our last term are perfect squares. Our middle term is has been doubled. All right, our middle term here, this negative 20x, had two identical terms that were combined together. All right, so that gets a little picky. We'll talk more about that later when we get into factoring. But this is a perfect square trinomial. So anytime you're multiplying two binomials, it doesn't have to be a linear times a linear, but anytime you're multiplying a binomial times itself, you're squaring a binomial, you're going to end up with this perfect square trinomial. All right, so that's something that is going to help us out in the future. If we can identify those when we see them, it makes math a lot simpler. All right, I'm going to erase this. We'll do 8 and 9 together kind of quickly, and then we'll be ready for individual practice. All right, so I'm going to try to do this so I don't have to erase anymore. So we'll do example 8 over here. So example 8 is 8r squared minus 2r times 5r plus 4. All right, so on this one, we don't have a linear times a linear this time. What we have is we have a quadratic times a linear. So we have a degree 2 times a degree 1, and and that's going to give us a higher degree as well. So let's watch our exponents really carefully, watch our signs. Just because our degrees are higher doesn't change the concept, so we're still doing the same thing. We're still going to do 8r squared times 5r. So 8r squared times 5r plus 4, and then plus negative 2r times 5r plus 4. So 8r squared times 5r, 8 times 5 is 40, and r squared times r is r cubed. Then 8 times 4 is 32. R squared times no r's is r squared. Then negative 2, remember that's a negative. Negative 2 times 5 is negative 10, and r times r is r squared. And then negative 2 times 4 is negative 8, and then there's only one r because the 4 doesn't have an r. So this one's a little bit different because when we get to our final term is not a constant. And it's not a constant because our second term in our first set of parentheses had a variable with it. So you really want to watch your r's. You don't want to get in the habit of these always being squareds, plain x's, and then constants. So pay really close attention to your exponents. The 40r cubed does not simplify. And then 32 minus 10 is 22, so plus 22r squared, and then minus 8r. So what we ended up this time was, instead of having a quadratic, we had a cubic function, or a cubic expression. So this one's a cube, so this one's cubic, because the highest degree is a cube. All right, highest degree is r to the third power. So that makes this one a cubic. So it's not the same family as the last one, but it is, still a polynomial. All right, so our final one, example 9. Look at example 9. I want you all to notice we have more variables now. This one's an x, this one's a y. This one's a y, this one's an x. So this one is going to change how our final result, what our product looks like. So we're finding products of two binomials, and we're going to do it the same way. So nothing changes. The steps are still the same steps. So 2x times 7y minus 3x plus 5y times 7y minus 3x. So if we always remember that first step, we don't have anything new we have to learn. We just do them all the same way. 2 times 7 is 14. X times y is xy. So that looks a little bit different this time. All right, but that's okay. It just looks different. We're going to still do the same steps. 2 times negative 3 is negative 6. X times x is x squared. Then 5 times 7 is 35. Y times y is y squared. And then 5 times negative 3 is negative 15. And then y times x is yx. We're going to get these in order by decreasing x values. So the first thing we're going to do is we're going to bring our negative 6x squared in. Then we're going to combine our xy terms. I've got 14 positive and 15 negative. So we're going to subtract 14 minus 15 is negative xy. And then our final term is positive 30 or plus 35 y squared. Okay, so this one looks different because we had two variables inside of our original factors. All right, so this video was quite a bit longer than the others. This is a pretty easy to understand concept once you get the hang of it. So just keep practicing. All right, keep practicing. And then our next video is going to be showing how to do a trinomial times a trinomial.